that place because the force applied to the index card is enough to counteract the frictional force. Thank you.
We are going to demonstrate an activity based on Newton's first law of motion. For that, we want a glass, a sheet of paper, and a coin. First, we have to place the paper on glass and the coin above the sheet. Now, when we apply force on the sheet of paper and remove it, the coin is at rest and tends to remain at rest. But due to gravity, the coin falls inside the glass. So, this activity shows us that an object continues its state of rest or uniform motion unless it is compelled by an external unbalanced force.
I am Mahika Murolia from class 9C. As for our evaluation project, I am going to demonstrate Newton's third law of motion, which states that every action has an equal and opposite reaction. And as we know that our physics laws of motion are not just limited to our textbooks, but we can see them in our everyday life. So, I am taking a very easy and simple example from our everyday life, and that is walking.
So let's have a closer look.
Here we can see that our feet pushes the ground and exerts a backward force on it, whereas the ground pushes us forward and exerts a forward push on us. So here we see that the force exerted by us on the ground is the action, and in turn the force exerted on us by the ground is the reaction. So here we can say that Newton's third law of motion helps us to know it's how we walk.
Good morning, teacher and all my dear friends. Here I am Supriya Rai of class 9C, here to demonstrate Newton's first and third law of motion. Here with me a bowl which is full of water. Now you can see that the water is in rest, but when I drop a water it comes in motion. This shows Newton's first law of motion. Now you can also see that when I drop water on the water surface, the water droplet exerts force on the water surface as an action, and the water surface also exerts force on the water droplet and it comes up as a reaction. This shows Newton's third law of motion.
I am Tanmay Saxena of class 9C. Today I am going to demonstrate an activity on Newton's first law of motion. It states that an object continues its state of rest in uniform motion unless it is compelled by an external unbalanced force. Now I am taking one glass. I am going to fill it with water. Now I am going to keep this glass on paper. Now I will pull this paper. In this activity the glass was in the rest, so when I pull the paper, the glass continue its state of rest because it is not compelled by an external force. In this activity I am taking some coins and a glass. Now I am going to keep a paper on the glass and few coins on the paper. Now I will pull this paper as I have done in the previous activity. Now in this activity when I pull the paper, the coin were in the state of rest. So when I pull the paper, the coin continue its state of rest and gone down in the water.
Good morning, ma'am. This is Mansi Sharma of class 9C, and today I'm going to demonstrate an activity which will prove the second law of Newton's second law of motion, which is force is directly proportional to ma.
Things required in this experiment are 3 different sized balls in which I have taken 3 different vegetables or fruits, tomato and 2 lemons of different sizes and shapes. Newton's second law of motion. Rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force acts, which is F is directly proportional to ma. Now I am going to take A and B as my first examples, and let's see go on its waves. Now I'm going to apply force to A in this direction, and let's see what happens. Well, B moved in the direction of A. So when I apply force to A towards B and they both clash, well, it has this force. Now if I do the same thing and replace A with C, let's see what happens. And I am going to give approximately same force as I did to A. Well, it hardly moves. So this shows that mass is directly proportional to, well, force. Now what if I hit B with C with a different acceleration? Well, that did move in the direction of C. This shows that F is directly proportional to ma.
Good morning everyone. Today I am Mansi Niswas and I am going to show you the live demonstration on Newton's first law of motion. As you all know, Newton's first law of motion indicates that an object continues its state of rest or uniform motion unless it is compelled by external force and balanced force.
Start.
For this demonstration, we will keep this like this. So now all the objects are at rest. Until then, I will apply them force. So as you see over here, when I applied the force, the coin, due to the gravity, it goes in the tumbler. Thank you.
Today I am going to demonstrate Newton's first law of motion, that is, an object continues its state of rest or uniform motion until it is compelled by an external non-uniform force. All the objects stay at rest before I apply force. As I apply force, the cardboard moves and the coin is pulled downward direction by the gravitational force.
Good morning, ma'am. I am Tanisita Fali from class 9C, where I will demonstrate the rocket balloon. We have studied about Newton's second law and third law. Newton's second law, the rate of change of momentum of an object is directly proportional to the applied unbalanced force in the direction of force. And Newton's third law, to every action there is an opposite and equal reaction. Materials required: a balloon, a tape, inflation pump, a straw, and scissors. First, we will take a straw and then we will cut it, half of it. And then we will put kite string inside of the straw. Like this. After that, we will inflate the balloon. After that, we will fix with one piece of paper. Now our
Good morning, ma'am. Today I am Ronak Meena of class 9C is here to demonstrate an activity. The material we require: a glass, a cardboard and a coin. Place the cardboard on the top of the glass. Now we place the coin on cardboard. You may see that there is no movement because it is at rest. Now we hit the cardboard. You may see that there was a sudden movement into the glass. The coin dropped because as there was a sudden external force or unbalanced force applying on it. So we may say that first law of motion says that an object stands to be at rest or in straight line until an external and unbalanced force act upon it. We may also call the Newton's first law of motion as law of inertia. Inertia is a tendency of an object to be at rest. Thank you.
Everyone, myself Anushka Patidar of class 9C and I am here to express Newton's first law of motion, which states that an object continues states of rest or uniform motion unless compelled with an external force. Here we have an activity. Let's get started. Here I have taken a glass filled with water, a piece of paper and few coins. Here I will place this paper on the glass, put these coins on this paper, and when I will pull this paper, as the paper is in motion, when I will pull this paper it will be in motion and the coins are at rest. These coins will insert in the glass. So let's do this. Here the paper was in motion and the coins were in rest, so the coins went inside the glass. Thank you.
Good morning, ma'am. Today I, Gauri Paliwal of class 9C is here to demonstrate the Newton's first law of motion. To demonstrate it, I may perform as activity. So, to perform the activity, the materials required are a card, a glass and a coin. Let's start the activity now. Place the card at the top of the glass. Now place the coin. You may see that there is no movement as the objects are at rest. So, we may now hit the card. You can see that there was a sudden movement as the coin drops into the glass. Why does the coin drop? As there was a sudden external force or unbalanced force acting on it. So, we may state that the Newton's first law of motion says that an object stands to be at rest or in straight line until an external or unbalanced force act upon it. We may also call the Newton's first law of motion as law of inertia. Inertia is the tendency of an object to be at rest.
I am going to demonstrate Newton's third law of motion, that is, every action has an equal and opposite reaction. This principle is used in rockets. For this, we need a balloon, scissors, straw, tape and a straw. Now this thread in the straw. When I release my finger, the air pushes out from the balloon. This is our action, and the reaction is the balloon travels same force with in opposite direction.
Hello, today I'm going to perform the famous card coin activity to prove the property of inertia of rest. The materials that we require are a glass, a stock paper and a coin. Here I have taken a 5 rupee coin. Procedure: take the glass and place the card on top of it, like this. After that, put the coin on top of the card. The coin should be at the center of the card. Now, quickly flip the card towards your direction and see what happens. Observation and conclusion. As soon as we slip the card, the coin falls into the glass. This happens because the coin still wanted to continue its state of rest. Hence, inertia is the natural tendency of an object to resist a change in its state of motion or of rest. Thank you.
Good morning, ma'am. My name is Arvind Singh Chauhan of class 9B, and today I am going to demonstrate an activity on inertia of rest. So for this activity, we have to take a piece of cardboard, a glass and a coin. So when we place cardboard on the glass and then the coin on the cardboard, we can see that the three objects are in rest or stationary. When we apply a force to the cardboard, the coin will flip down. From that we can learn that inertia of rest is the tendency of an object to remain at rest until and unless the force is applied. So when we apply a force on the cardboard drop down, but the coin remain at rest and drop down on the glass. Thank you.
My name is Vibhu Gupta and I am studying in class 9C. Today I am going to demonstrate an activity based on Newton's first law. To demonstrate this activity, I have taken a glass, taken a cardboard and a glass and a coin. First we have to put the cardboard on the glass and then the coin, and then put. This shows that inertia of motion is a tendency at rest until and unless force is applied. When we apply the force on that CD, the CD has gone and coin is at rest.
I am Priyanshu Tiwari of class 9C. I am here to explain you about the Newton's first law of motion. Newton's first law of motion states that an object is at rest or in uniform motion unless an external force is applied on it. We will do by doing an experiment. First we will take a glass, a coin and a cardboard. First we will take glass, then put a cardboard and take a coin. The coin stays on the index card because the force applied to the index card was not greater than the frictional force. Now we take a glass, a coin and a cardboard. First we will take glass, place the cardboard and take a coin. The coin stayed in one place because the force applied to the index card was not great enough to counteract the frictional force.
Ma'am, I am Rishi of class 9C and I am going to perform a task regarding Newton's first law. Newton's first law states that every object remains in uniform motion or at rest position until and unless external force is applied. So we have football, it is now at rest position. If we kick it, it will comes in motion and after some time it will comes in rest because of the external force friction is applied on it. Against the football is at rest and if we apply force on it, it will come in motion. This proves Newton's first law. Thank you and
Newton's first law of motion states that every object remains in rest or uniform motion until and unless any external force is applied. To demonstrate the first law of motion, we need a sheet of paper, a coin and a glass. We'll put a paper on a glass and a coin on the paper. And if we'll apply force on the paper, the coin will suddenly fall into the glass due to gravity. But the coin will remain in rest only.
Good morning everyone, my name is Sanya and my activity is based on Newton's first law of motion. So, what is Newton's first law? His law states that every object will remain in rest or in uniform motion in a straight line unless it is compelled to change state by the action of external force. Now, let us perform an activity to see how it works. For this experiment, we require a A3 paper and a heavy object. Place the paper on a flat surface, then place the bottle on it. Try to pull the paper as fast as possible. What do you notice? The object does not move though the paper was pulled away. The experiment demonstrates how the concept of Newton's first law works. An object in rest remains in rest and an object in motion remains in motion unless acted by an unbalanced force. Thank you for
Class 9C demonstrating an example for the Newton's first law of motion. In Newton's first law of motion, an object in rest stays in rest and the object in motion stays in motion with the same speed and in the same direction unless external forces are applied. Now see, 3 coins and a card.
Presenting an activity on the topic Newton's first law of motion. In Newton's first law of motion states that a body in rest will remain in rest and a body in motion will remain in motion. By this definition, we will do an activity. Let's do the activity. By this activity, we have proved the Newton's first law.
Good morning, ma'am. I'm Vivek Yadav, demonstrating the second chapter of physics, force and laws of motion. As you can see that this object is at rest because the upward thrust provided by my hand is equal to the gravitational pull, and we know that unbalanced force cannot change the state of any object. So if I start releasing this object, it will fall as it turns into an unbalanced force. So we know that any object in motion will remain in motion until and unless any external force is applied on that body from the first law, Newton's first law. And in this case, the table is providing that force to stop this pen from moving, because according to Newton's third law, we know that every action has an equal and opposite reaction. So due to gravity, this pen exerted some force on this table, and in reaction this table applies some force on this pen, thus making this pen stop moving. Thank you.
Good morning, ma'am. Today I am Saket Sagar of class 9C present here to demonstrate you with the topic Newton's third law of motion. So I will conclude you with our activity. We have put the air in it. If we go to it, activity you see is made by me able to cover the weights. Pressure exerts from the air balloon, and there are 2 actions from the balloon and the tires. In third, we cannot say which object the action is taking place. Thank you. See you.
I am Aditi Pal. Today, I will verify the equations of motion through a practical demonstration. Now, I will throw a ball from 1.2 meter and then record its time. So, this is marked as 1.2 meter. So, we have got the time 0.5 seconds. So, we have got initial velocity as 0.0 meter per second, acceleration as 9.8 meter per second square. Now we will put the time in our first equation. Now we have got the distance as 1.2 meter. Now we will solve the second equation and find the initial velocity. Final velocity is equal to 4.9 meter per second.
So velocity square is equal to 24.01, which is equal to 4.9 square. So all the equations are verified. Thank you.
A very hearty good morning to all of you present here. I am Vishishtita Dubey, and today I am going to demonstrate Newton's first law of motion using an activity in which I have taken a pile of 5 rupee coins, and this coin I am going to strike this pile of coins with the one coin, and let's see what happens. So this was my coin from which I have strike, and one coin came out from the pile. So the question comes that why only one coin went there and not the other? So as we all know, the first law of motion is an object remains in the state of rest or of uniform motion in a straight line unless compelled to change the state by an external force applied. So the external force I applied was this coin, and I applied force to only this coin, and the rest of the coin cannot change their tendency of being in rest. So these coins did not went there.
Very question of class 9C. I am here to say about the Newton's first law. The Newton's first law says that a thing cannot change, stop, or change direction, stop or start all by themselves. It requires some force from the outside to cause such change. It's also called inertia. The first law of motion is also called The first law of motion is also called the law of inertia. Now we will start an activity of glass, cardboard, and coin. Now we will put the cardboard at the top and then coin, and we have to slip it, and the coin get inside. A body at the rest or uniform motion will continue to be at the rest or uniform motion until or unless not need external force to act on it. At its take us more effect or force to heavy mass. This direct relate to the proper known as inertia. Hence, the first law of motion is also known as the law of inertia. Thank you, everyone. This is very crucial.